definitely an interactive presentation. So all you guys need to do is bring up just like a bash terminal that you can install Nmap on, CentOS, or excuse me, anything like that will be fine. You don't have to have a terminal up. You don't have to, you can just follow along visually. Can everybody see my screen okay?
Mm-hmm.
Should be looking at a bash prompt.
Yes.
Awesome.
And
So,
for anybody down in the lower left-hand corner, there's a slider to make your two different screens bigger or smaller.
Yes. Yeah. If there's anybody who's having trouble seeing, I can give you a second. All right. So this presentation is on Nmap performance tuning. If you see me looking off to the side, I've just got my notes here. I want to make sure I don't really miss anything. This is going to be focused almost entirely on performance tuning, but I'm going to touch on basic port scanning a little bit. We're going to have a lot of interactive examples, and then here on my display you'll be able to see some examples of what I've done in the past with working with. So what is Nmap? It is a network mapping tool. You can run vulnerability exploit scripts with it, but you can also do comprehensive port scanning, which includes discovering open ports as well as services that are on them, as well as service versions for those services. So we're just going to be focusing on port scanning today. We're just going to be focusing on service discovery and whether or not ports are open. So I was trying to think of a use case to describe with this, and one of the more common ones in the context of day-to-day work is system security plans, is preparation of SSPs. And so at some point in the future, or at some point in your past, you may have been asked to prepare ports and services for an SSP so that they can store it and turn it in with an accreditation package or something like that. Nmap is just the best free tool to do it. It's available on almost every distro. I've never run into a distro it's not on. So that often begs another question: why bother tuning the performance? What is the point? If you're only going to drop your scan times a nominal amount. And the simple answer to that is that traditionally for SSPs, you're talking about SYN scanning for TCP ports. But occasionally you'll get asked to do UDP scanning as well. And that's where you really start to see, degradation in scan performance. And it's exponential. I mean, you could see if a TCP scan because oftentimes for accreditation packages, you're talking about systems where they cover multiple subnets. So you wind up in this situation where you're doing discovery scans and service scans, all these different types of port scans on multiple /24s, your multiple subnets, and that might only take a few hours for TCP, but it can take in the magnitude of days, or some of the estimates we were seeing early on would take weeks for UDP scans. So we'll get into why it's that much slower. A lot of it has to do with just the nature of UDP. But first, we're going to look at a very, very basic scan. So I'm going to start right at the basics of Nmap. We're going to get into a lot of the direct command line utilization of Nmap. And I'm just going to keep it super simple. Anyone who's messed with this before, you've probably seen a good bit of this. And then obviously, if not, this will be a nice primer for you. So if you have your terminal up, or if you're just watching mine, and you can see here, basically the simplest way to run a scan would just be specifying command name Nmap, and then I'm just going to do localhost, but you could specify IP, host name, whatever else. Now what that does is it runs through, and localhost is always going to be faster just because it doesn't have to traverse any interfaces. It just runs straight on loopback. And what that does is it checks the top 1,000 ports. And those ports, there's a nmap-services file in user share nmap that tracks those top 1,000 ports. And it changes via different versions and updates to the package. Basically as Nmap evolves, as those top 1,000 ports change, the contents of nmap-services change. And you can specify, you can actually specify, let's try it here. So there's actually a way to see what those ports are on the command line as well instead of digging it up. So you can do nmap-b, O, capital G, and then just a plain dash. And what that plain dash represents on the command line syntax is no hosts. I'm saying don't go out and run a scan, just tell me what you're doing with no host specified. So you can see there, these are the top 1,000 ports that it checks when you just do as we did before. So if I run this again, nmap localhost, it's going to go back up, check those specific ports, and those are the ones there that you found to be open. Common stuff, 3389 for, it's got, this is Linux Academy, so it's got some oddball stuff on it, but of course, standard ports for RDP, SMTP, SSH, that kind of thing. So that's a very, very basic scan. And then a full TCP scan, you would specify -p and what you would do. And I'm going to keep the sample size small here, but with -p, you can specify any range of ports. You could go, or 1 to 65,535, or in our cases, and the test that I did preparing for this, I'm just going to do 20 to 25. That gives us two pretty common ports, 22 and 25. So with SS, and I'll explain what SS here is in a second. Localhost. Oops. Go to sudo up. Okay, so there you go. You see it ran through and it found multiple ports closed and a couple open there. So what that SS does is it specifies SYN scanning, because you can do with S capital T, you can do full TCP connection scanning, wherein for every port it goes through the entire three-way handshake and it specifies a full TCP connection per test per probe per port. So why specify SS? Well, we'll get around to that. So SYN scanning in general is faster, but it's also the default behavior for Nmap. It's not doing full TCP connection scanning by default. SYN scanning is the default behavior, typically because it's sufficient to determine what service is running. You generally don't need to run, if you wanted overkill, you could do full TCP. So the reason I specify SS there is to get you familiar with the switch, because there is a separate switch for UDP. And I'm just so here, I'll go over some of these. So the issues with UDP are that the ports can be rate limited, which means that they're only going to respond to so many requests per second. And so with UDP, to get it to respond, you oftentimes have to craft the right type of probe to get it to respond at all. Otherwise, it's just not gonna respond. So if a port is rate limited, you might see that correct probe fail. So oftentimes it comes back and says that it doesn't know whether or not a port is filtered or closed or open or whatever else. I already touched on that. So I just want to make sure I don't miss anything, because I tried to lay out points to get this across. So oftentimes rate limited, it will come back as closed or filtered, which you'll see in the results as closed pipe, filtered pipe, or board. So basically Nmap doesn't know whether or not it's recognizing the probe and denying it, or there's like a firewall that's just blocking the connection altogether. So next thing we're going to do is we're going to just build on what we've already done here. We're going to go back through and we're going to tell it, and this is why I specified SS. You want to specify S capital U, because if you do this and you only specify S capital U, just a quirk with the invocation, if you only specify S capital U, you're only going to get UDP results. And I actually saw that happen where somebody turned in one of these scans and it didn't have any TCP and they just didn't notice in the results. That's just a quick little quirk to get around. And their thought process was solid. They thought this is to add UDP because TCP is the default behavior. You actually have to specify both. So That.
I've got a quick question for you.
Yeah, sure.
Well, because this is where I'm teaching and how it notifies you of services and everything else. And typically on Linux systems, when you're using these network commands and it's giving you this common port, it gives you it back maps it to that common service.
Mhm.
So here you've got 20 is FTP data, 21 FTP, 22 SSH, and so on and so forth. But port 24, it's coming back with the service priv mail.
Yeah.
And that's not defined on a Linux system in the etc services file. So do you know where Nmap is getting its service names from
So
by chance?
I don't know specifically what the data source is, but I know that they have an assumed list of services. Basically, what it'll do is if it checks a port and it can't get a positive result, like you see there, it's listed as closed. I don't like with the nmap-services file, there's something like that that it pulls from that tells it this is what you should have been looking for. So it's closed, and if it were open, this is what's probably here. So it's basically just a standard port in the sense of Nmap, not in the sense of like IANA specification.
Well, and the reason I asked about that is when you get these security scans coming up a lot, your tool, whatever tool it might be, if it at least with Nmap it's listing the ports, but in some cases it throws out a service name, but that's not actually the service you're running on there. It incorrectly identifies it based on that service mapping file. So that
Right.
was the
So
point of the
that
question.
is one instance where unless you're getting, because we'll actually touch on that with service version detection, you do have to actually take a lot of things Nmap gives you with sort of a grain of salt and sort of in stride because so many things until you get like a validated, service version on a port that you just have to kind of say, okay, this is something for me to check. And that's really what Nmap's service is in terms of remote scanning. It's not, here's a 100% guarantee of what's on your box. It's, here's what the outside perspective is to someone who might be targeting the security posture of the system. You know what I mean? So if that's the way they see it, what do we have to do? Because if priv mail isn't on there, and it doesn't matter if an outside attacker sees it. You know what I mean?
It looks like that Nmap actually stores it in user there Nmap services. It stores it in a little local database for itself.
Okay, so it would be the same file as the ports then.
Yes, yeah. I actually just dropped it into the into chat.
Nice. Okay, very good. Yeah, well, hey, there you go. So you don't even have to look for another spot for it. It's right there with the ports. Awesome.
At least
Thanks,
according
Doug.
to Nmap site.
No, that's cool. That's awesome. Thanks, Doug. Yeah. But does that sort of answer your question, Travis?
Oh yeah, I was just curious. I knew it was a file somewhere. Um, it would have been nice if it used the same file as the Etsy services, but
Right.
you know,
Yeah, actually it would be because then, well, but I guess, I don't know. The other thing is they're probably trying to, I don't want to say make it OS agnostic because obviously you want to be able to tell, but I don't know. To an extent, I'm sure they were trying to standardize. You know what I mean? All right. So next up, we will get into the performance tuning aspect, but before that, there are a couple sort of quality of life, sort of ergonomic switches that I like to add. And those are, first of all, OS detection, because adding OS detection with, it doesn't matter where you add these as long as it's before the host. Obviously, the man page will give you the syntax for what order the options need to go in. But so capital O will just give you OS detection. And then I also like to add, and actually a lot of times for SSPs, they don't demand OS detection because they assume that if you have a system, you're going to have a general idea of what's running. But it depends. Are you trying to discover new hosts potentially, rogue hosts potentially on that subnet, or so that's just one thing you can tack on there, and it doesn't dramatically increase scan times at all. You can add -D and then a number that you specify up to 5 will give you a debug level. I just set everything to 2. That's just kind of what I've always used, and it just gives you, more than anything, it just gives you an indication that the scan's progressing and not just getting hung up on one port, because a lot of the output will tell you whether or not it's cycling probes on the same port over and over. We'll get into why it might do that. So next, -V, same rule, 1 through 5. I just always set it. So then that gives you a nice, pretty little. Now, keep in mind, this is more useful when you're scanning subnets, because you don't want to be sitting there staring. So if we had, I don't know, like looking at this top scan here, where I ran this, you would be staring at this for your subnet until it finished without those flags. So, and that, get a nice little output there, 3.16 seconds. So, obviously that would be far higher if you were scanning subnets. Results here.
Just a comment, Jake. If you're actually scanning full subnets at work, that's a good way to piss off the security team or network team.
So it is, unless they're asking for it.
Yeah.
In a lot of use cases, you will be asked for SSPs, you'll be asked to do it, essentially. You know what I mean?
Right. Yeah. I'm just commenting that if you do it without security's knowledge, sometimes you'll get a nasty email.
Oh, absolutely. Yeah. Just to make sure that gets 100% driven home, this should all be done in the context of like a notified full scan window where you got the system owner's permission. Yeah, obviously don't just run and perform these scans at any point in time, especially like Doug said on multiple subnets. So, or any super sensitive systems. And we'll actually, when we get into the tuning, we'll actually talk about sort of benchmarks for network performance that can impact that, and how you should adjust some of these parameters accordingly if you're on a particularly, I guess fragile network would be a way to put it. Okay. So one thing I want to show you next is, and this will be a trivial difference in this case, but it will be a difference. I want to show you running localhost versus running on a remote host. So as you see, we just ran it on local and we got 3.16 seconds. So if I turn around and I run this on another host sitting on that same subnet out in Linux Academy, take just a hair longer. Still nothing crazy, still just using internal IPs. So you see you got 7.81 seconds. And of course that extrapolates out, and when you're talking about running it on tons of remote hosts and more than 6 ports per host, massive performance degradation. And of course that's running TCP and UDP together. So, and actually that is a little longer than it was in testing too, because just in case it made a liar out of me, I wrote down my times from before, and in testing it was 6.98 seconds. So let's take a couple looks at some. So let's say you're already scanning your subnets. You've got like Doug pointed out, you've got your scan notice out. You got the system owner's buy-in, and you are good to go. They say, it's after hours. You scan away, and but you don't want to be there until 5 a.m. So you start trying to tack on performance parameters, because you're looking and you're getting output in your verbose information that says it's, I don't know, 20% done and it's been 2 hours, and you think, well, I really don't want to hit Control C, but Jake had those performance parameters that might help with this. So one thing you could tack on there is -- max - retries, And I'm going to go off the book from this just because I don't want to tell you guys anything wrong. So max retries is going to stop Nmap from attempting a retransmission of a probe beyond a certain number of times. This is by default, it will try a probe on a port 10 times. And it can actually increase that if it deems it necessary. And I'm not, 100% sure what specifically causes that to go up or down. It's something in the negotiation of figuring out what the port is running. So setting that at 10, according to the documentation, which is nmap.org, and actually here I'm going to post this in chat in case anyone wants to read it while we're going to town here. I'm gonna chat real quick, right under Doug's link. And a lot of what I'm going to be talking about comes from this specific page, too, if you guys kind of want to dig through. Okay. There we go. So, according to that documentation, setting it at 10 is fine, and you can also set it as low as 3. And usually, since Nmap only attempts 1 retransmission per probe, it's never rising higher than that. And 3 is just the number that, the Nmap maintainers recommend, and they don't recommend setting it lower than 3. We can go ahead and set that. And keep in mind, our number here, we're trying to get this down from 7.81. So that's our benchmark that we're trying to lower this from. So we've got 3 max retries, which means it's not going to retry a probe more than 3 times. So next we have --min-parallelism. And you can run these separately. You can, and if you are running these on your own systems, just, to play around with them, I encourage you, mix and match, see what works best for your environment. But obviously you want to be a little more careful if you're running on impactful systems. So min-parallelism makes sure that Nmap is sending a minimum number of probes to a host at one time. It makes sure that at no given point is it going to sort of slow and only be working on 1 probe per port at a time. So, and actually, sorry, I misspoke there. It is not probes per port. It is probes per host. So it is simultaneous probes that it can be. Now, I will say the documentation says that this should be tuned as a last resort. I have run into the use case where the authorizing official for the systems we were scanning said, tune whatever you have to tune as long as the results are still, they are still high fidelity, accurate results. So the documentation calls out a value of 10, which means it will never run more than or fewer than 10 probes per host at any given time. So it does call out that on a healthy network, this number often rises into the hundreds. So if the network itself is, not experiencing latency issues or anything, setting this isn't really going to do anything for you because it's already, rocketing sky higher than that to begin with. Let's see. So we've also got next up --min-rate. And then, so what this is the number of packets that it will send per second. And this can actually impact accuracy. So this is something to be careful with. The documentation does talk about calling out a value of 300, which again, you only want to do if this is on a healthy network. And obviously, ping round trip times of I don't know, just a few milliseconds, obviously you're fine. And it's up to you to kind of know what's too high for your network. And if you are coming at it from a security perspective and you've been asked, as you might be if you were in my position in the past, to scan networks that you hadn't even touched before, really, this is something where you want to ask. You want to go in and say, what is the latency like on your network? Use admins, use, the system owner, and get in and actually figure out, what is the ecosystem that you're working with before you go firing off this setting. But if you do set it You can set 300, which means it will never be sending fewer than 300 packets per second to the hosts. Okay, now this one we're going to talk about, but we're not actually going to use. It is --min-host group. This is where your subnet scanning comes into play, because what you can do is you can specify a minimum host group. You can say, I want you to never be working on fewer than 50 hosts at any given time. You shouldn't be, just concentrating on 10 hosts or whatever else. This is something that Nmap will tune dynamically, so if you use it, it is another one to be careful with, because if Nmap is running 10 hosts at a time, there's probably something it saw in the network that caused it to do that, or it's concentrating on particularly troublesome hosts. So we do not have to use this because we are only trying to get one host's scan time down from 7.811 seconds. But if you're scanning subnets, that's one thing to use. So we have reached my favorites. These are the ones where, when I was playing around with the setting, this really, really, really dropped the UDP scan times, oftentimes from like 8 hours to 16 minutes. I mean, we are talking just have it done before the 9:30 call, as opposed to letting it run all day while you're trying to figure out, if you're going to be able to turn it in before so-and-so leaves. So it's really, really a dramatic decrease, and there are two of them that work in tandem. They are --initial round trip time, RTT timeout. If I can spell, and I can't see all of my prompt anymore. I like looking at you guys, but not that much. So, so the documentation talks about never setting these values below 100 milliseconds. And basically what this does is, sorry. I was trying to find again why this is so impactful. And basically what it boils down to is when you are running these scans, if a UDP port doesn't respond, obviously just because it could be rate limited or closed or whatever else, you're not forming your probe correctly. If it doesn't respond, one of the ways that Nmap can interpret that is, the host is slow, because there's no good way for Nmap to know, at least not that I've seen from working with this, for Nmap to know the host is not the thing that's bogged down, is not the thing that's taken its sweet time. So if Nmap assumes the host is slow, it can jack up these timeouts to seconds per probe. And I mean, we're talking potentially sometimes hundreds of probes per port per host on the subnets that you're scanning. So it can really, really just exponentiate the scan times. So if you tune this down, documentation calls out 100 milliseconds. It will say per probe, do not wait longer than 100 milliseconds. Or it might be, I'd have to look again. But essentially, no, it's per probe. There it is. Don't wait longer than 100 milliseconds for it to finish, essentially. And you can tune that up if you're only needing, if the network's, you can play around with it. If the network's a little fragile and you're like, well, I'm going to try it on one host, you can tune that. Like I remember I did 500 milliseconds for one of the systems where the system owner was like, well, we're not sure about this string. So we played around with it. And again, if you're flying blind with this, when preparing SSPs, you often will be, because you're not an admin on the system directly. Get with people from the system and have them sort of advise you on the network's health. And there's ways to test it yourself, obviously. And then that works in tandem, and I'll talk about what each does. We've got max round trip timeout. And all this does, the only reason why you have to set both is because for the first probe, it can try to get an initial value of what that should be. And it just, I mean, at that point, you're shaving seconds off, but I just do it anyway. Because essentially what you're saying is don't even make an assumption. Don't even try to guess. We already know that we're doing UDP scanning. So tack on this and just start out at 100 milliseconds and running. So with all of these added to it, we're doing SYN scanning with SS, and we're doing UDP scanning with SU. And so with all of those tacked on here, the number we're trying to get down from is 7.81 seconds. If we run it now, it fails. Why did it fail? Because I didn't specify. No, I did. Bear with me a second.
Is parallelism spelled correctly?
Why we copy, yeah, it's not spelled correctly, is it? Parallelism. Is that right? Nope. No, that's right.
Have it out.
Yeah. Yeah. Nope, it's not spelled right, is it? Hey, there we go. Yeah, foiled by typos. So you see there, we essentially shaved 15-ish% off of this. Took it down from 7.81 to 6.14. I know that's pretty insignificant here, but again, when you're talking about, shaving 20% off of 8 hours, that's a far greater improvement. So, else here. So I did make this note that it can be difficult to extrapolate how much of an improvement you get, because obviously here you get 15-20%. But I did make a note that I had seen, like some of these are like 80%. Because the one that I distinctly remember is we had one that was set to run roughly 8 hours, and after applying this to it, it ran at about 16. Any questions? Pretty straightforward. It's all just mostly, command line invocation, just something that could save you a headache in the future. You guys ever messed with this tool before?
All the time.
On the home network.
All right. Well, that's what I've got.
Thanks, Jake.
Thank you.
Thanks for watching and sort of following along. Thanks for helping me with my spelling. Everybody